Hi there, are you ready for the new workflow we have prepared for you? Let's go now through the mining one together.
We will see how the new Reconstructor 4.2 release can speed up your job in mining and land environment areas, sensibly increasing your productivity. Starting from the creation of a dam model from a point cloud or a mesh, we will move on extracting isolines and contours, crest and toe, the discontinuity of the 3D model, quick profiles, and we will experience how to compute volume and cut and fill volume as well. This workflow has something for everyone. All these tools are included into the mining add-on, so no need to jump from one software interface to the other, and no need to use any extra Reconstructor add-on. You won't also have the risk to lose yourself during the elaboration, because all the functions are listed sequentially in the toolbar. Let's start from an already pre-registered ng-reference point cloud. To create the dam model, select the corresponding command dam points in the toolbar, and the recipe windows will support you in the process. You can use one or more point clouds, it does not matter. The goal is extracting a regular grid. Here, we can extract a grid of 1 meter and then decide which points keeping. For example, keep the lowest point in order to create a DTM, or you can compute an average value of the position of the points into your grid in order to extract a dam. Once set, click Compute, and different items can be extracted. The first item created is an orthophoto, with its related depth grid map. The second item is a point cloud, and the last one is a list of points, representing the single points of the point cloud. Select the item point cloud and name it. The new cloud is saved in the project window. Let me increase the cloud's point size for a better visualization. In the property browser window, select the option point size and increase it. If you want to discover more about the property browser usage, have a look at the dedicated video. The point cloud created offers several possibilities. You can export it directly for further post-process, for example, in specific topographic software, or you can use it to create a mesh in order to get a regular dam model. As you know, Reconstructor supports several models to create meshes. The one I suggest to use is the Topographic Mesh, mostly used in land environment and generally in mining applications. I do not want to bother you with the Topographic Mesh creation, just remind that you can access the command directly in the mining toolbar. Let me upload the Topographic Mesh that I have previously created and move on with this, extracting the isolines. To extract the isolines, we will experience the new Contours tool. This tool can be run both on point cloud and mesh, and you can activate it from the mining toolbar. Create a new Contours survey and name it. In the recipe window, you can choose the distance between the slices, the upper and lower altitude that you want to use to extract the isolines. Let's start from an altitude of -90 meters up to 0 meters. The software shows you a preview of the cutting planes. Let me set as a slices distance 20 meters, for example. You can then check the cloud slices result in the section view inside the Reconstructor workspace. If you want to check the polylines result, open the section viewer. Remind that you can run the contours extraction using more models, so if you want to define and estimate the differences between two models, like check excavation or blasting, for example, in the section viewer you can visualize the polylines results extracted by the two models, as we are displaying here. The contours output, listed in the project window, is a group that contains polylines, orthophotos, and slice of points. A very valued tool is the discontinuities extraction, crest and toe, warmly used in mining applications, especially in open pit one. Select the mesh you want to use and run the command. Here, you can easily extract polylines according to the discontinuities of the surfaces. Toes are displayed in red and crest in blue. You can choose if you want to close the gap or erase only the short edges, in order to get a smoother and continuous polyline. The obtained polylines can be saved in the main Reconstructor project under the Polylines item group. Crests are the ridges and toes the valleys. We have seen how to extract isolines, break lines, and what about the vertical cross-section? Don't worry, we are following the sequential suggested workflow in the mining toolbar, and we are going to experience now the Quick Profile tool. Create a new survey and name it. At this stage, you should be already an expert. As you can feel, the to-do extraction processes are very similar to each other. That makes it easier for the user remembering the main steps. Pick the profile, clicking on 2 points onto the mesh, and arrange the plane dimension as your convenience. Of course, you can extract multiple profiles, so just fill in the number and the spacing between them. Press Compute and open the section viewer to visualize and check the result. The last function that we have to perform to complete our mining analysis is the volume calculation. Reconstructor has the ability to compute two kinds of volumes. Standard volume respects a reference plane. This tool is present in the main Reconstructor package, and the cut&fill volume, whose function is available only in the mining add-on. Let's start from the default volume 1. To calculate the volume, we have to select the mesh and the reference plane. The volume can be calculated above or under the plane, using the Smart button in the recipe window. You could be interested to calculate the volume of a specific area. Take the polyline that defines the area and drag it in the recipe window. Polyline can be both imported or created in Reconstructor. The volume preview appears in the Reconstructor 3D workspace. Press OK to perform the computation, and the resume window will show you the volume preview. Click Get PDF Report to create the customizable PDF document.
The second volume computation, the cut&fill, compares the variation between two different meshes. So, apart checking the differences in 2D, as we have seen before with the isolines extraction, you can also estimate the differences in 3D by the volume. Let's use two meshes representing the scan position at time 1 and the scan position at time 2. In the recipe window, drag the corresponding meshes. As optional, you can choose a reference plane and a polyline, in case the cut&fill interests only a specific area. A very interesting option for the users who work in the mining field is calculating the volume respect regular benches. For each bench, Reconstructor creates a reference plane that can be used to extract the isolines at that specific altitude. Don't worry if the computation takes a while. Once done, you can save a customized PDF report with the result of the differences in volume between mesh at time 1 and the mesh at time 2, as well as the differences at each bench. I hope that the mining workflow has been useful. I wish you a successful job with Reconstructor and stay tuned to discover the next one.